Kia ora, Year 12. In this video, I want to look at one of the Dr. Frost differential equation questions that I've set because it involves some partial fraction work as well as some good work at manipulating the solution into a particular form. But it's also just a really good example of a real-life DE question. So we're told we've got a population of meerkats on a nature reserve, and that's being studied by a team of conservationists. And the DE is a little bit harder than what we're used to. And if you look at it here, you can think about what that looks like. If we've got the population here, this is not going to be the equation for population, because obviously that's what we're trying to find out, right? That's the end goal. But dp by dt is an upside down parabola. So you can think about what's going on in here in real life with the meerkats. What we're saying is that once the population hits 5,000, the rate of change of meerkat population starts to become negative. In other words, they start to die off faster than they're growing. And that will be to do with how much land and food is available for them. Okay, so this is a pretty common model that you'll find quite often. We're going to look at it later on in a scholarship calculus session as well. Now, in the Dr. Frost question, they gave you the partial fraction split up that we're about to see, but I'm going to work through that here so that you know exactly how to do that. The first thing that we're going to do is to separate the variables. So we're going to have 1 over p times 5 minus p dp is equal to 1/15 dt. Just as we always do. And now we want to go on and integrate both sides. But we see that here we have to do some kind of partial fraction split because as it stands, this thing is a nightmare to anti-differentiate. So let's do that. Let's just find a blank page to do that on. So 1 over p and 5 minus p can be split up into something over p plus something over 5 minus p. Doing my usual partial fractions work gives me this. I'm going to let p equal 0, and that gives me 1 is equal to 5a. A is 1/5. And then when we let p equal 5, we get 1 is equal to 0 plus 5b. So b is also 1/5. So that means that I can go back and now split this up into two things. So doing that in the integral gives me 1 over 1/5 times 1 over p plus 1/5 over 5 minus p dp is equal to 1/15 dt. So integrating that now gives me 1/5 times the natural log of p minus 1/5 times the natural log of 5 minus p, and that equals 1/15 t plus c. So here we've got 1/5 of the natural log of p over 5 minus p is equal to 1/15 t plus c. I'm going to multiply both sides through by 5, giving me this. And then I'm going to stop for a minute and we'll just have a look at what's going on. Now notice here that when I times that c by 5, I'm left with c here as well. So I've got a choice about whether at this point I keep on going and get my equation p equals blah, blah, blah. But it's often better to go back and use the information we've got and try and get rid of any constants that we can as soon as possible. So in this question, going all the way back to here, we were told that when t is equal to 0, the population is 1. In other words, when at the start there are 1,000 meerkats in the nature reserve. Now let's see if I can find the page I was on. Okay, here we go. Right, so we're going to use this information that when t equals 0, p equals 1, and we're going to substitute in now and solve for the value of c. So the natural log of 1/4, so I can lose those absolute value signs now, is equal to 0 plus c. In other words, c is equal to the natural log of 1/4, which we can rewrite if we want to as c is equal to the natural log of 1 minus the natural log of 4, which is negative log of 4. So let's go back now and put all of that into here. and keep on going. So we've got the natural log of p over 5 minus p is equal to 1/3 t minus the log of 4. Now we're going to e to both sides. So we have e is equal to e to the power of 1/3 t minus log 4. Here we've got p over 5 minus p is equal to e to the power of 1/3 of t times e to the negative log 4, and I would have been better to have left that as the log of a quarter. So that gives me this, p over 5 minus p is equal to 1/4 e to the power of 1/3 t. So we're just about there, except that we're asked to get an expression p equals blah, blah, blah. So we have to do a little bit of rearranging. So p is equal to 5 minus p, but this is really just level 2 algebra from here on. We just have to be careful with how we do it. So we want all of the stuff with p separated out. So let's do 4p is equal to 5 e to the 1/3 t minus p e to the 1/3 t. Gathering up the stuff with p in it on this side gives me p into 4 plus e to the 1/3 t is equal to 5e to the power of 1/3 t. So we're just about finished. P is equal to 5e to the power of t over 3 divided by 4 plus e to the 1/3 t. Go right back to the start of the question, and we were asked to get it into this form. So you'll notice that in the numerator we've just got a constant, and in the denominator we've got an e to the negative 1/3. So we're going to do that by dividing the top and the bottom by the same thing. We're going to divide both of them by that. So p is equal to 5 over 4. I'm doing this really slowly because this is probably the first time you've seen this. We can go a bit faster next time. So p is equal to 5 over 4 e to the 1/3 t plus 1. Okay, so what you should do when you finish this, and I haven't got to open another window to do it, is hop into either Desmos or GeoGebra and just have a look at what that population looks like. Okay, so it's worth making sure that you can think about what that DE was when we started it. Right, so this is my rate of change. Right, so we started with this and we ended up with this form of equation for the population. Thanks for watching. I'll do a few more that you're having trouble with later on today, as long as the puppy cooperates.